bag of banana chips in your cupboard. It's an industrial marvel traveling through a 14-stage manufacturing odyssey where AI inspection systems catch defects invisible to human eyes, all before reaching your home. In this video, we're pulling back the curtain on the hidden mega factory operations behind one of America's favorite snacks. You'll discover exactly why some banana chips cost twice as much as others, and whether that premium price actually delivers better quality or is just clever marketing. The secrets we'll reveal about this humble snack might surprise you. Ever wonder where the millions of bananas processed daily actually come from? Those perfect crunchy chips you're snacking on start their journey thousands of miles from the factory floor. The global banana chip industry is massive, with some facilities handling over 500,000 bananas every single day. The journey begins on sprawling plantations across the tropical belt, from the lush fields of Ecuador to the humid farms of the Philippines, Thailand, and Costa Rica. Specialized banana varieties like Saba and Cardaba are cultivated specifically for chip production. These varieties contain higher starch and lower sugar content than your standard Cavendish supermarket bananas, making them ideal for the perfect crunch. Timing is everything in the banana chip world. The harvest must occur at precisely 75 to 80% maturity. Workers skilled in determining this exact ripeness stage carefully cut down entire plants to capture the fruit at its prime. Too early and proper flavor compounds won't develop. Too late and excessive sugar makes proper crisping impossible. The supply chain operates like a finely tuned global orchestra. A single factory might source from up to 12 different countries throughout the year, shifting procurement as growing seasons change across hemispheres. When Ecuador's production slows, the Philippines ramps up. This complex logistics web ensures factories never run out of raw materials despite seasonal limitations. This intricate network constantly battles threats from Panama disease, black sigatoka fungus, and devastating climate events like typhoons in Southeast Asia or hurricanes in Central America. Major manufacturers maintain sophisticated agricultural forecasting teams that would make meteorological departments jealous, tracking weather patterns and crop yields across continents. Once harvested, the clock starts ticking. Bananas must reach processing facilities within 48 to 72 hours before quality deterioration begins. Specialized refrigerated containers maintain precise temperatures of 56 to 58 degrees Fahrenheit and control humidity levels, essentially placing the fruit in suspended animation during transit. These high-tech containers cost upwards of $30,000 each and require constant monitoring. Some even feature ethylene scrubbers that remove this natural ripening hormone from the air. At the factory gates, quality control inspectors enforce ruthless standards. Factories processing 100+ tons daily might reject up to 15% immediately. Many rejected bananas would look perfectly fine to the untrained eye, but fail specialized refractometer tests measuring sugar content. Anything above 12% gets rejected. Size uniformity must be 3 to 4.5 centimeters in diameter, and even minor bruising that can cause texture inconsistencies during frying. This global ballet of cultivation, transportation, and precision quality control is what ensures that perfect crunch in every bite of your banana chips. Those strict size requirements aren't just arbitrary standards, they're dictated by the multi-million-dollar machines waiting inside what engineers call the transformation zone. This is where ordinary bananas undergo a high-speed metamorphosis that defies what most people believe is physically possible. Would you believe the entire journey from whole banana to perfectly sliced chip takes just 7 minutes? Inside this zone, bananas encounter automated peeling systems that make kitchen knife skills look prehistoric. These robotic peelers use pressure-sensitive grippers that apply precisely enough force to break the peel without damaging the fruit. The most advanced factories employ machines that strip and process up to 400 bananas per minute. That's nearly 7 bananas every second, with 0 human contact. Creating these machines presented engineers with a serious challenge, designing equipment that handles naturally inconsistent products with surgical precision. Every banana arrives with unique curves, density variations, and ripeness levels, like a high-speed ballet where machines and fruit must dance in perfect precision. The solution combines artificial intelligence with real-time adaptation. Before reaching the cutting stage, bananas pass through optical scanning stations where cameras capture exact dimensions from multiple angles, creating a 3D model in milliseconds. The system automatically adjusts blade positions, cutting angles, and slicing speed for each specific banana. The precision required is extraordinary, explains one factory engineer. We're talking about machines that detect and adjust for dimensional differences smaller than a human hair. After peeling, specialized water jet systems operating at pressures exceeding 1000 psi blast away lingering peel fragments, ensuring only pure banana flesh continues to the slicing stage. This washing process improves oil absorption during frying, creating a more consistent final product. The slicing stage is critical. Premium chips maintain a thickness of 1.8 to 2.0 millimeters, while standard varieties range from 2.3 to 2.8 millimeters. This difference dramatically impacts texture and mouthfeel. Thinner slices create crispier chips, while thicker cuts produce a heartier crunch with more pronounced banana flavor. Advanced factories implement cryogenic flash freezing before slicing. By rapidly cooling bananas using liquid nitrogen systems, the fruit temporarily hardens, allowing cleaner cuts with less cellular damage, ultimately resulting in chips with superior texture. Industrial slicers featuring titanium alloy blades spin at up to 2,000 rotations per minute, creating thousands of uniform slices every minute. These cutting systems cost upwards of $750,000 each, with the largest factories operating multiple units simultaneously. The blades require replacement every 8 to 12 operating hours due to natural silica compounds in bananas that gradually dull even the hardest metals. What's impressive is how adaptive these cutting systems are. Each slicer contains microscopic sensors that monitor blade resistance. When detecting changes in density or firmness, the system automatically adjusts blade speed and feed rate in milliseconds to maintain consistent slice thickness between individual cuts. Those pristine banana slices won't become the crispy snacks you love without undergoing a fascinating chemical transformation. While perfect cutting is impressive, what happens between slicing and frying is where ordinary fruit becomes engineered for maximum crispiness. This little discussed pre-treatment phase completely restructures the banana's cellular composition. After slicing, those perfect banana discs enter the crucial solution phase, a transformative stage that prepares them for their final crunch. Slices are submerged in specialized chemical baths containing precisely calibrated mixtures of citric acid, ascorbic acid, and sodium metabosulfite. These compounds fundamentally alter the banana's cell walls. Think of it as a microscopic reconstruction project where acids simultaneously break down certain structures while reinforcing others. The acidic environment dismantles pectin while strengthening cellulose networks, creating the perfect structural foundation for crispiness. The citric acid performs double duty during this process. It prevents the enzymatic browning that would turn slices an unappetizing brown while initiating the dehydration essential for proper oil absorption. Manufacturers maintain the pH between 3.2 and 3.8, the perfect balance where banana tissue maintains integrity while still undergoing necessary chemical changes. Premium facilities incorporate sophisticated sugar reduction systems during pre-treatment. Natural banana sugars can caramelize too quickly when fried, creating bitter flavors and uneven coloring. Engineers have developed extraction processes using osmotic pressure gradients. Imagine tiny channels drawing excess sugar away from the fruit tissue to achieve the ideal 8 to 10% sugar content where crispness and flavor reach their peak. Consumer taste tests consistently rate these precisely calibrated chips higher for texture and overall satisfaction. Advanced factories enhance flavor through vacuum pressure infusion systems during pre-treatment. Rather than simply coating the exterior after frying, these systems create negative pressure environments that drive flavoring compounds deep into the banana's cellular structure. When pressure normalizes, these compounds become locked within the fruit tissue. The difference is immediately apparent, explains Dr. Martin Reeves, food scientist at the International Snack Technology Institute. Surface-applied flavoring dissipates quickly, while pressure-infused flavoring delivers consistent taste profiles throughout the entire eating experience. The pH balancing stage follows, normalizing natural acidity variations 4.5 to 5.8 pH to the ideal 4.2 pH level, where banana flavors are most pronounced while maintaining structural integrity. Specialized equipment featuring real-time monitoring systems accurate to the 100th decimal place makes this possible, with automatic dispensers adjusting chemical concentrations every 15 seconds based on continuous analysis. Color preservation technology completes the pre-treatment process. The distinctive golden hue comes from controlled oxidation using precise concentrations of natural compounds like turmeric and annatto. These bind with specific proteins in banana tissue, creating color complexes that resist fading even after months on store shelves under bright lighting. Advanced facilities can produce up to 27 distinct golden shades, creating brand-specific signatures that consumers unconsciously recognize. That golden hue is just the beginning beginning of banana chip perfection. What transforms those soft, moisture-laden slices into crunchy, shelf-stable snacks happens inside industrial fryers that operate with aerospace-level precision. When was the last time you maintained your cooking oil within half a degree while processing 3 tons of food per hour? After the chemical pre-treatment prepares each slice, the real transformation begins in continuous fryer systems stretching over 100 feet. These industrial giants cost $4.5 million each and process up to 4 tons of banana slices hourly. A precision-engineered conveyor network submerges each slice for exactly 2 minutes and 45 seconds. The sweet spot for perfect crispness. The temperature control would make your home cooking look like child's play. These systems maintain oil temperatures within plus or minus 0.5 degrees Fahrenheit across thousands of gallons. We're talking about 48 separate sensing points throughout the system. Even a single degree fluctuation ruins an entire batch. Temperature stability is everything, explains food engineer Sarah Connors. The difference between a perfectly crisp chip and a burnt or soggy failure comes down to maintaining 347 degrees Fahrenheit with virtually zero fluctuation across tons of cooking oil. The technology goes deeper. Computerized oil management continuously filters, tests, and replaces oil to maintain specific chemical properties. Advanced analyzers test oil every 8 minutes for 27 different quality indicators. When parameters drift, automated systems inject fresh oil while removing degraded portions. The most advanced factories employ vacuum fryers, creating negative pressure environments. This lowers water's boiling point within banana tissue, allowing cooking at 266 degrees Fahrenheit instead of 347 degrees Fahrenheit. The result? Chips with 42% higher vitamin retention and better flavor. The oil itself features engineered fatty acid profiles, typically blends of high oleic sunflower oil with specialized palm fractions. These custom blends provide heat stability while enhancing the banana's natural taste. Some manufacturers guard their oil formulations as closely as Coca-Cola's secret recipe. Pressure control creates distinct textures from identical bananas. Low pressure during initial frying creates larger air pockets for a lighter crunch. Increased pressure during final stages produces denser, crispier textures perfect for dipping. Despite massive energy requirements, these factories achieve surprising efficiency. Heat recovery systems capture thermal energy from exhausted oil and steam, recycling it throughout the facility. The most advanced plants recapture 65% of their thermal energy, reducing carbon footprints while saving millions. Real-time monitoring watches every chip. Thermal imaging systems scan chips passing through the fryer, creating heat maps revealing internal moisture content. When improper moisture levels appear, the system automatically adjusts conveyor speed, oil temperature, or immersion time. Some facilities even use hyperspectral imaging technology developed for military applications. These systems analyze molecular composition and motion, detecting everything from moisture distribution to sugar caramelization. This data feeds into AI systems that continuously optimize parameters for each banana batch. Artificial intelligence doesn't just optimize cooking, it's the ruthless gatekeeper determining which chips make it to your snack bowl. After surviving the precision fryer, each banana chip faces judgment from systems so sensitive they can detect a blemish smaller than a grain of pollen. Welcome to the quality control gauntlet, where perfection isn't just preferred, it's mandatory. These inspection systems operate with military-grade precision. Think of them as the world's pickiest food critics with superhuman abilities. Chips travel down specialized conveyor belts where multiple high-speed cameras photograph them from every angle, capturing 64,000 frames per second. AI systems analyze these images in milliseconds, rejecting chips with microscopic flaws invisible to the human eye. Our neural networks can detect a hairline fracture as small as 20 microns, about 1/5 the width of a human hair, explains Dr. Elena Vasquez, head of quality systems at Chiptech Industries. To put that in perspective, a speck of dust is around 40 microns. What looks perfect to you might be instantly rejected for flaws you couldn't possibly see without a microscope. The perfectionist judge doesn't stop at appearance. Advanced laser spectroscopy examines each chip's chemical composition, spotting issues like moisture pockets or oil distribution problems. Chips that might spoil prematurely are immediately discarded despite looking perfect. One missed detection could mean an entire batch reaches consumers with off flavors, potentially damaging brand reputation overnight. Even the sound of each chip matters. Specialized acoustic monitoring stations analyze the distinct cracking sound when chips are broken. The perfect banana chip produces a specific acoustic signature, says audio engineer Marcus Chen. Too moist, and the sound dampens in certain frequency ranges. Too dry, and you get a brittle crack instead of the ideal crisp sound. Our systems detect these variations instantly. Weight-based sorting follows, measuring chips with precision down to 0.01 grams. Critical for ensuring packages contain exactly what's promised on the label. High-speed systems group chips by weight categories for precise packaging, despite natural variations in size and density. Metal detection and X-ray inspection stations scan for foreign particles with remarkable sensitivity. These systems detect metal fragments as small as 0.3 millimeters and can identify non-metallic contaminants like plastic, stone, or glass that might have entered during processing. Surprisingly, after all this technological scrutiny, human taste testers still play a crucial role. Trained experts sample chips from each batch, evaluating flavor notes and texture profiles. Machines can tell us if a chip meets specifications, but only humans can tell us if it's truly delicious, says Maria Gonzalez, senior flavor technologist at Pacific Banana Processors. We've had batches that passed every instrumental analysis but didn't taste quite right. That's when we stop production and recalibrate. The combined result of these multi-layered inspection systems is staggering rejection rates. In premium chip production, up to 18% of chips are rejected for quality reasons most consumers would never notice. This perfectionism explains much of the price difference between budget and premium brands. Those perfectly inspected and fried chips wouldn't last a week without the invisible shield protecting them right now. The packaging preserving your banana chips uses barrier technology originally developed for military rations in extreme desert conditions. What looks like a simple foil bag is actually a feat of material science that's constantly fighting against the forces trying to destroy your snack. After rigorous inspection and precise frying, only the highest quality chips advance to packaging. Their golden perfection now needs armor against the enemies of freshness. Behind the scenes, the packaging stage operates at mind-boggling speed. Modern filling lines process up to 200 bags per minute. That's more than 3 packages sealed every second. These machines precisely weigh each portion down to 0.1 grams using high-speed vibration tables that separate and distribute chips for consistent fill levels. The packaging serves as a microscopic fortress, a protective armor shielding your chips against oxygen, moisture, and time itself. Before sealing, the packages are flushed with nitrogen gas, reducing oxygen content from 21% to less than 0.5%. This modified atmosphere packaging MAP technology virtually stops oxidation processes that cause rancidity, extending shelf life from weeks to months without additional preservatives. The packaging industry battles in an eternal tug of war between preservation and sustainability, explains Dr. Amelia Chen, Packaging Innovation Director at Food Tech Solutions. Manufacturers have developed hybrid materials, combining conventional plastics with biodegradable polymers derived from plant starches to address environmental concerns while maintaining protection. The films themselves consist of up to 7 microscopic layers, each serving a specific purpose. The outer layer provides structural integrity and printability for branding. Beneath that, a specialized nylon layer offers puncture resistance. The critical middle layer creates the most impressive defense system in this protective suit. It contains aluminum oxide or silicon oxide particles embedded in polymer. Each square inch of premium packaging contains over 8 billion individual barrier platelets, notes packaging engineer Robert Tanaka. Oxygen molecules bounce between these platelets like pinballs, extending their journey through the film by up to 2,000 times the actual thickness. The innermost food contact layer maintains integrity even when exposed to oils in the chips. Premium brands use specialized polymers, while budget brands often use simpler films that gradually allow oil migration, contributing to that stale taste in lower quality products. Quality control for packaging is equally meticulous. Ultrasonic seal verification systems test every package, measuring acoustic response to detect imperfections as small as 5 microns, about 1/10 the width of a human hair. Advanced facilities apply a microscopic ethanol mist charged with specific ions to neutralize static electricity before packaging, improving efficiency by up to 23%. The final bags undergo compression testing and automated vision inspection before shipping. Random samples face accelerated shelf life testing in environmental chambers that simulate months of storage in just days. This attention to packaging explains much of the price difference between premium and budget banana chips. Premium brands invest in packaging materials materials costing up to 4 times more than standard alternatives, a crucial component of delivering that perfect crunch to your taste buds. There you have it, the extraordinary journey of the humble banana chip from tropical plantation to your pantry shelf. What looks like a simple snack actually represents one of the most impressive feats of food engineering on the planet. Think about it, high-tech equipment worth millions, AI systems smarter than most computers, and packaging developed with space-age technology, all to create that perfect crunch. Does knowing this hidden journey make your next crunch even more satisfying? Premium brands charging more invest in better raw materials, precise technology, and stricter quality control, giving you chips with better flavor retention and ideal crispness. Next time you're enjoying a snack, look around your kitchen and wonder what other everyday products hide engineering marvels. Hit subscribe for more videos that reveal the remarkable technology powering ordinary products we take for granted.